This SOS video is using the substitution method to solve a system of linear equations algebraically. So remember that a solution is an ordered pair that's going to make both equations true in a linear system. When we substitute, we replace a variable with an equivalent expression or with a number. So here's the steps to solve a linear system using substitution. First, we're going to isolate one variable. We'll get either x or y by itself. Then we're going to substitute that variable in the other equation with its equivalent expression. Don't worry, I'll show you how to do that in a moment. Then you're going to solve for the remaining variable because there's only going to be one letter to solve for in the equation. Once I get an answer for that variable, I'm going to substitute that number in either equation and I'll find the second variable. And then we write the answer as an ordered pair. Remember, check your answer in both equations because if it's a solution for a system, it needs to work for both equations. It will make both equations true. Okay, so our directions read, solve each linear system algebraically. When we solve a system, we are looking for the common solution, the ordered pair that makes both equations true. So here I have two equations with the same two variables, x and y. I want to see, does either equation have a variable by itself? And it does. The first one has x by itself. So I know that x is worth the same as 2y plus 3. X has the same value as 2y plus 3. That means when I look at my next equation, wherever I see x, I can replace it with this same value, 2y plus 3. So that's what I'm going to do first. In place of x, I'm replacing x, I'm substituting the equivalent expression. 2y plus 3 minus 9y equals 11. Now, what math can I do? That's right, we're going to distribute. So 4 times 2y is 8y. 4 times 3 is 12. Minus 9y equals 11. I want you to pause the video and solve for y. Okay, so once we distributed this, we combine like terms. 8y and negative 9y is a negative y. Negative y plus 12 is 11. The opposite of adding 12, subtracting 12. And we have negative y equals negative 1. So this is the same as multiplying by negative 1. So to get rid of that, we're going to divide by that same number. Divide both sides by negative 1, and we get y equals 1. So now we have the value of one of the variables. So what we do is we go back to either one of these equations. I'm going to pick the easiest one, the simpler one to work with. You can pick whichever one you want. And I'm going to write it again. X equals 2y plus 3. Now, since I know that y is 1, wherever I see y, I'm going to replace it with its value. X equals 2 times 1 plus 3, and that means x equals 5. 2 times 1 is 2, plus 3 is 5. So I think my solution is the ordered pair 5, 1. But remember, we want to make sure that that solution works for both equations. So I'm going to write check. I'm going to write the point I have to check, 5, 1. And I write above it x and y to remind myself which is the x value, which is the y value. We need to substitute this in both equations to make sure it works. So let's write the first one, x equals 2y plus 3. In place of x, I'm going to put my x value 5. In place of y, I'll put my y value of 1. And let's make sure that works. So is it true that 5 equals, well, 2 times 1 is 2, plus 3 is 5. Yep, they're the same number. All right, let's substitute that ordered pair in the second equation. 4x minus 9y equals 11. Pause the video, substitute that in, and then see if that works as well. Okay, how'd you do? We substituted 5 in for x. We substituted the y value 1 in for y, and then we did our math. 4 times 5 is 20. Negative 9 times 1 is negative 9. And is that true? 20 minus 9 equals this 11? And yes, it does. So since that ordered pair worked for both equations, we can now say this is a common solution. Solution is an answer that makes the equation true, and common means it works for both of them. Okay, let's take a look at our next system of equations. A little bit more challenging because I don't see a variable by itself, but I do see that this is a coefficient 1y. So I say, what if I can just move this over? Well, the opposite of 4x, positive 4x, is a negative 4x, and I would write that on both sides. 4x and a negative 4x is a zero pair, and I get y equals negative 4x minus 2. So I have now isolated my variable. I know that y has the same value as negative 4x minus 2. Wherever I see y, I can replace it with its equivalent value. So I take a look over here, I say, oh, I see y. So instead of writing y, I'm going to write its equivalent value, its equivalent expression. 3 times negative 4x minus 2 plus 2x equals 14. Okay, I'd like you to pause the video, distribute this, and solve for x. Let's see what you get. Okay, how'd you do? First, we distribute the 3 outside. 3 times negative 4x is a negative 12x. 3 times negative 2 is negative 6. And we copy the rest. Then we combine like terms. Negative 12x and a positive 2x is a negative 10x. Negative 10x minus 6 is 14. And now use your skills in solving equations to get x by itself. We added 6 to both sides. We got negative 10x equals 20. And instead of multiplying by negative 10, we divided by negative 10. And x equals negative 2. Remember, whatever you do to one side of the equation, you need to do to the other. Okay, we now have the value of x. Let's find the value for y. We can pick any equation we want. Again, I'm just going to take the simpler one. Makes it easier. If x has a value of negative 2, wherever I see x, I can replace it with its equivalent value. So we have 4 times negative 2 plus y equals negative 2. Negative 8 plus y equals negative 2. Instead of subtracting 8, we're going to add 8 to both sides. That's a zero pair, and we get y equals 6. So I think my common solution is a negative 2, positive 6. I don't know for sure until I check it in both equations. So let's do that. We're going to check the point negative 2, 6. Remember to write x and y above it to keep track of what your values are. So I write my first equation, 4x plus y equals negative 2. In place of x, I put my x value. In place of y, I put my y value. And I do my math. 4 times negative 2 is negative 8. This is plus 6 is negative 2. And a negative 8 and a positive 6 is a negative 2. So great, that worked for that equation. But remember, it has to work for both equations. So let's write the second equation. You're going to pause the video, replace the y and x with these values, and make sure it makes that equation true. Okay, how'd you do? Remember, we're not putting just the first number. This says y, so we have to put the y value of 6. 3 times 6 plus 2 times the x value, negative 2, does that equal 14? So 3 times 6 is 18. Positive 2 times a negative 2 is a negative 4. Does that equal 14? And 18 and a negative 4 does equal 14. So 14 equals 14, true. So that means our ordered pair, negative 2, 6, we can call our common solution. It is an answer that makes both equations true. Okay, so you have now used the substitution method to solve a system of equations algebraically. Congratulations.